Welcome back, everyone. This brings us to the end of our section on how to design and implement cross-VNet connectivity using network peering. Before we move on to the next section, let's quickly review the main points that we covered and go through another case study scenario. In this section, as is tradition, we started with a high-level overview of Azure networking peering concepts, in which we learned that network peering is a method to extend your network specifically using only Microsoft's private backbone to connect multiple virtual networks. This is overall a great low-cost and high-performance option. We also compared network peering to VPN, which, as we just mentioned, peering by comparison gives you a faster and private connection with no encryption over Microsoft's private backbone, whereas a VPN connection has more limited bandwidth, does traverse the public internet. However, it does have the advantage in that it provides encrypted traffic between networks. We then moved on to taking a close look at how to enable traffic across multiple networks using network peering, in which we covered our golden rule that network peering by default is non-transitive. However, when paired with a VPN connection, you can achieve transitive connectivity with peered networks when including in a VPN connection. However, you do need to know that when enabling VPN over peered networks, the host network needs the additional peering configuration of allowing gateway transit from its network, and a remote or peered network needs to enable the use remote gateway configuration to take advantage of the host network VPN gateway. We then moved on to taking a close look at the hub and spoke network topology, which is a very popular model for large Azure network implementations, in which we have a single hub network, just like a wheel, connecting to many multiple spoke networks. This is really ideal for a wide variety of centralized network management scenarios. Moving on, let's once again take a look at a case study scenario with our favorite fictional bakery Control-Alt suites. In this case study scenario, our favorite bakery has two network peering requirements that we need to think about. The first is that we need to extend our Azure networking infrastructure to multiple locations, specifically multiple regions, and we need to keep all those network communications private on the Microsoft backbone. Second, as our network implementation grows, we need to plan out how to centrally manage all of our different connected networks traffic, in which we want all of our VNet to VNet traffic to all go through a central firewall, regardless of where that traffic is originated from. With these scenarios in mind, let's go ahead and review how we can fulfill both these requirements. So, starting with the first requirement to extend our network privately across multiple regions, not surprisingly, the best option would be to create network peering connections to extend our reach over Microsoft's private backbone, in which you take two virtual networks and then simply set up a bidirectional peering connection between the both of them to enable private networking. Next, to fulfill our requirement to create a centralized hub to force all network traffic through a centralized firewall, we will go with the option of expanding our network implementation to adopt a hub and spoke model, from which we will configure it to route inter-VNet traffic through a centralized firewall within our hub VNet virtual network. Once properly configured, whenever traffic is moving outside of one of the spoke networks to either the hub VNet, to the external internet, or if our virtual appliance is forwarding traffic to another spoke network, all that traffic will be routed through that primary central point for security reasons. With that will bring us to the end of our section on network peering. Let's now go ahead and move on to the next one.